Hello students, in this video we will discuss problems on limits using LHospital rule. Observing this question, let f of a is equal to g of a is equal to k and their nth derivatives are existed and not equal for some n and limit x tends to a of this function is 4. Then find out the unknown value k. Here first primary observation, in the last video also I explained, observing here, replace x by a, what happening? F of a, g of a, minus f of a, g of a into f of a, plus g of a, all terms will cancel. And g of a minus f of a. Here f of a is equal to g of a, that's why this is also 0. It's very clear, as x tends to a, this is what 0 by 0 format. Now using LHospital rule, we will try to remove that format, that is 0 by 0 form. Okay, now limit x tends to a, now we should differentiate numerator and denominator separately. What happening? F of a is constant, derivative of g of x is g dash of x minus derivative of constant 0 minus g of a into derivative f is f dash of x and derivative of g of a is 0 because of constant divided by g dash of x minus f dash of x. Observing here is equal to 4. Limit x tends to a, here observing f of a and g of a is equal to what? K. Replace these two terms by k, what happening? K into g dash of x minus f dash of x divided by g dash of x minus f dash of x. What is given observing here? Nth derivatives are existed means what here? First derivative, second derivative and so on. All derivatives are existed. Here what is given here? Nth derivatives are not equal for some n. That's why very clear here. G dash of x is not equal to f dash of x is possible. That's why we should cancel now these two. Therefore, limit x tends to a k is what? 4. That's why k is equal to 4. Okay. Now one more question we'll discuss. Limit x tends to 0, cosecant x minus 1 by x. This is also one JE model. Replace x by 0, what is happening? Cosecant 0, undefined, it's infinity, 1 by 0. So, which is of the form infinity minus infinity? This is also one of the indeterminate form. Indeterminate form, infinity minus infinity. Okay, now observing here, limit x tends to 0, cosecant x means 1 by sin x minus 1 by x. Limit x tends to 0. We should take now LCM as x sin x. That is x minus sin x by x sin x. Now observe here, replace x by 0, 0 minus sin 0, 0, 0. Finally 0 by 0 form. That's why now we should apply LHospital rule. So very clear, limit x tends to 0, what derivative of x minus sin x? 1 minus cos x. Now derivative of x sin x, x cos x plus sin x. Okay, and now again replace x by 0, what happening? 1 minus cos 0. Very clear, 1 minus 1, 0. Now this is 0, this is also 0. Again now 0 by 0 form came. That's why again one more time we should differentiate. So limit x tends to 0, 1 minus cos x derivative. What happening? Sin x divided by x cos x derivative minus x sin x plus cos x plus sin x derivative cos x. Now replace x by 0, what happening? Sin 0, 0 by, this is very clear, 0, cos 0, 1, this is 1, finally 0. So, as x tends to 0, cosecant x minus 1 by x, it tends to 0. Okay, now one more question. This is also JE model already given. Now, limit x tends to 0, log of 3 plus x minus log of 3 minus x by x is equal to k. What about k value? Now, primary observation. Replace x by 0, what happened? Log 3 minus log 3, cancelled. 0. Again 0 by 0 form came. Okay. Now, we should apply L'Hospital rule. Limit x tends to 0, log of 3 plus x. Log x derivative 1 by x. So, now we should apply here 1 by 3 plus x. Derivative of 3 plus x, 1, very clear. Minus log of 3 minus x derivative. 1 by 3 minus x. Here inner function is what? 3 minus x. Derivative of 3 minus x, minus 1. Divided by x derivative 1. Is equal to what? Okay. Now replace x by 0, what happened? 1 by 3 plus 1 by 3 is equal to what? K. Therefore, k is equal to what? 2 by 3. One more question observing here. If f of x is differentiable at x is equal to a, then limit x tends to a, x square f of a minus a square f of x by x minus a is equal to what? Now first primary observation. Replace x by a, what happening? A square f of a minus a square f of a. 0 by a minus a, 0. Very clear, 0 by 0 form. That's why now we should apply L'Hospital rule. Limit x tends to a, x square derivative of 2x into constant f of a minus a square into f of x derivative f dash of x divided by x minus a derivative 1. Very clear, denominator is 1, that's why a won't come 0 by 0 form in the next step. That's why now replace x by a, what happening? 2a into f of a minus a square f dash of a. It's enough. Okay, now I go for one more question. Limit x tends to 0, 5 power x plus 3 power x minus 2 power x minus 1 by x is equal to what? So, very clear here, first primary observation, 5 power 0, 3 power 0, 2 power 0 minus 1. What happening? Very clear, all terms will cancel by 0. So, it is also 0 by 0 form. That's why we should apply L'Hospital rule. Then what happening? Observed. Limit x tends to 0. Here, one basic formula I should apply now. d by dx of a power x log a. Okay. Now 5 power x derivative. 5 power x to log 5 plus 3 power x to log 3 minus 2 power x into log 2, derivative of constant 0 by 1, x derivative. Okay, right. Now here, denominator is 1, no problem, the next step won't come 0 by 0 form, as x tends to 0. Now replace x by 0, what happening? 5 power 0, 1, 3 power 0, 1, 2 power 0, 1. That means what? Log 5 plus log 3 minus log 2. Using logarithm property, log a plus log b, log a b. So, very clear, log 5 into 3, 15 minus log 2. Again using log a minus log b. So, very clear, 15 by 2. So, as x tends to 0, this function tends to approaches to log of 15 by 2.